channel. How are you all doing? Myself Sahithi. So I have decided to give some short break for my vlog. So when I give a break for my vlogs, you must understand that I will be discussing lessons with you all. So I am a student of grade 10. Myself Sahithi, as the channel name says you all. So today we will be discussing the light, reflection and refraction chapter. Got blasted, right? Because this chapter, it's very important in our 10th grade. It's very important in physics, especially it is very difficult to learn also. Especially the ray diagrams are very important. Refraction is the most important concept, so I decided to keep this refraction in a separate part. But in today's video, we'll be talking about the light and reflection. Reflection. So first of all, let me give you a brief idea about what we are going to do in today's lecture. First of all, we will discuss what is light. That is, we'll be discussing about the dual nature of light. Dual is nothing but it shows the properties of two elements. I'll say that detailedly, but before that, let's see. And in reflection also, we'll be discussing what is reflection, laws of reflection. We have two laws of them. And in this, we'll be even discussing types of mirrors. One is plane mirror and the other one is spherical mirrors. Plane mirrors, normally we have only plane mirrors. We'll be discussing the properties of it. And spherical mirrors, we again have two types of mirrors. One is concave mirrors and convex mirrors. And in those concave and convex mirrors, we'll be discussing about the rules of how to draw ray diagrams. And then ray diagrams we will see like when it is placed at infinity. So we have total 6 ray diagrams in concave, whereas in convex we have only 2, so it can be done very easily. And nature of these, and we'll be even seeing the uses of the concave and convex mirrors. Finally, we'll be doing numericals based on the mirror formula, sign convention and magnification. So very important lecture. So I hope you will all enjoy it and even listen it carefully without any pauses. So without any further ado, let's get started. Okay guys, so as the name of the chapter suggests, light, reflection and refraction, the first term here we can say is light. So it's very important to discuss what is light, right? So this is the basic topic about light, that what is light. These are all the elements of light. First one is light is a form of energy. You should always remember. Now energy is a scalar quantity, thus light will also become a scalar quantity. Remember this topic. Light is a form of energy, energy is a scalar quantity, therefore light is also a scalar quantity. Fine. Now light shows dual nature. Light has a dual nature. Now what is dual? See, it means that it shows both wave and particle properties. That means it travels in the form of wave and it can even travel in the form of particle. Now the property which shows that the light can travel in a wave is diffraction, and through particle form is photoelectric. See guys, we don't have these both concepts right now. We are not going to cover this because we don't have these concepts. Just for a quick idea, I have mentioned it, we don't have this in NCERT also. And this light, we can say it's an electromagnetic wave that can travel both in medium as well as vacuum. It's an electromagnetic wave that can travel in both medium and vacuum. And in vacuum, the speed of the light is 3 into 10 to the power of 8 meter per second. Remember this guys, because this is very important. This is really very important. 3 into 10 to the power of 8 meter per second. So this is everything about light guys. Light is a form of energy. As energy is a scalar quantity, light also comes into the category of scalar quantity. Light is shows a form of dual nature, that it shows both the properties of wave and particle. So light, we can say simply that's an electromagnetic wave that can travel both in medium and vacuum. In vacuum, the speed of the light is 3 into 10 to the power of 8 meter per second. Now we will see the speed of the light in different various mediums. Okay guys, so here we have the speed of light in different mediums. We have water, glass, air, diamond. But wait, I forgot to tell you guys the main property, that light always travels in a straight line. Light always travels in a straight line. This property is termed as rectilinear propagation. क्या बोलते हैं इसको? Rectilinear propagation. The speed of light in different mediums. Light speed in water is 2.25 into 10 to the power of 8 meter per second. Now I may ask, is this important as per exam? Yes, it's very important. Light in water is 2.25 into 10 to the power of 8 meter per second, and light speed in glass is 2 into 10 to the power of 8 meter per second. Light speed in air is 3 into 10 to the power of 8 meter per second, and light in diamond, this is the least important one, but then also if you grow up, this will be most important. It is 1.25 into 10 to the power of 8 meter per second. Guys, No need to memorize this. If you study it twice, you will get it. Light in air and light in water is important. Just note that in it. And light always travels in a straight line. This property is called as rectilinear propagation. Now let's get into the refraction topic. Okay guys, now let's talk about reflection. Light topic is done. That was everything about light. Now let's talk about reflection. What is reflection? You were hearing this word since your 6th grade. Yes or no, say me. You were hearing this term since the 6th grade. And you know the definition of the reflection. If no, then don't worry, I am here to help you guys. So reflection is nothing but bouncing back of light. As a 10th grader, you should write bouncing back of light after striking the surface. After striking the surface. और एक और चीज भी इधर आप चाहे तो ऐड कर सकते हैं. If you want, you can add one more thing here. Bouncing back of light in the same medium. In the same medium. Suppose the medium is air. In the air only, when the incident ray falls on a surface, in the air only the reflected ray also passes. Now, if it is coming in air, it does not go to vacuum, right? So this is very important. So this is the actual definition of reflection. As a 10th grader, you should write this. Bouncing back of light in the same medium after striking the surface. Now let's describe about this surface. So surface बोल रही हूँ मैं. So what type of surface it is? किस तरह की surface की बात कर रही हूँ? So the surface must be smooth, shiny, and even polished. Polished, it should be backside. It should be polished properly at the backside so that the reflection could take place smoothly. Polished should be backside. This is everything about reflection. This is just the definition. Now I will share one important topic with you. So listen it carefully. We have the laws of reflection, but before that, let me say you this diagram. Show you guys this diagram. Let us understand the concept of reflection very deeply. Suppose we have a smooth surface. Suppose this is a smooth surface. Okay, write it down here. This is a smooth surface. Now, suppose this is an incident ray coming and falling on the surface. This is an incident ray coming and falling on the surface. Arrow marks are very, very important because it's very important to describe which one is incident ray and which one is reflected ray. So, write it down here. This is incident ray. We'll finish off this very quickly because this is not as important because you have all studied it in your previous grades. Now a normal is drawn in between after this. This is a reflected ray. See, the arrows are very important. Now you may ask why this normal is to be drawn. See, let me say normal is always drawn perpendicular to the surface, and the main reason we have drawn this normal is to show that the angle of incidence is always equal to the angle of reflection. Now what is this angle of incidence, angle of reflection? You may have got that out. The angle formed in between the incident ray and normal is called as angle of incidence, and the angle formed between the normal and the reflected ray is called as angle of reflection. And as per the first law, and this normal is very important to show that angle of incidence is equal to angle of reflection. And now in this only we will be talking about the laws of reflection. Two laws are there in laws of reflection. So the two laws of reflection are, the first law is angle of incidence is always equal to angle of reflection. Note it down guys. Angle of incidence is always equal to angle of reflection. This is incident ray, this is reflected ray. Incident ray comes here and makes a angle between incident ray and the normal. Angle of reflection is formed between the reflected ray and the normal. Okay, got. Now the second point is that incident ray, reflected ray and normal, all of them lie on the same smooth surface. All of them lie on the same smooth surface. Okay, incident ray, reflected ray and normal, all of them lie on the same smooth surface. All of them lie on the same plane. So this was everything about reflection. If you want to take a screenshot, you can. I am aside of the camera. Okay. So this is everything about reflection. Now let us talk about the types of images because that is another important topic to be covered. Okay guys, now let's get into the next topic, that is types of images. Types of images is very important topic because this is going to help us in understanding the convex and concave mirrors better. When is this real image formed? When is this real image formed? It is formed when reflected rays meet at a certain point. When reflected rays meet at a certain point. And now, as these reflected rays are meeting at a certain point, the image formed will be inverted. So you may ask a doubt that why is this image formed will be inverted? Why is real image inverted? This is because when the reflected rays meet at a certain point, the outcome of the image will be inverted, and this image, this is very very important, it can be obtained on a screen. An example is the theaters. जब आप थिएटर्स में जाते हैं मूवी देखने के लिए, जैसे कि ट्रिपल आर, मैं सिर्फ एग्जाम्पल दे रही हूँ, जैसे कि आप ट्रिपल आर मूवी में गए और आप NTR का टाइगर सीन देख रहे हो या फिर कुमरम भीम सॉन्ग देख रहे हो. And why are you able to see that? That is because of the real image formed. That is because reflected rays are meeting at a certain point to produce the image on the screen. Okay? So that is what happening there. So it can be obtained on the screen. Now talking about the virtual image, this is another important. Now real image is nothing but a concave mirror, because in a concave mirror also the same condition takes place. What happens is that the reflected rays meet at certain point. Let me draw the diagram here. Suppose very small diagram I'm drawing. This is a concave mirror. We will describe what is concave and convex also. If you have a confusion, watch this video. Upcoming I will be sharing the topic of concave and convex. Now this is concave. So how can you say this is a concave? Because ये जो होती है ना केव की तरह होती है, जैसे कि ये होती है हमारी केव, तो ये सब कुछ है हमारी कॉनकेव, ये है हमारी पॉलिश्ड सरफेस, ये है हमारी रिफ्लेक्टेड सरफेस. दिस इज कॉनकेव. अगर कॉन्वेक्स की बात करें सो इट विल बी लाइक दिस इज कॉनकेव. इट इज the reflecting surface is bulged outwards, whereas in concave the reflecting surface is bulged inwards. So this is the concave mirror. So this is the polished surface. Before that, before we start doing this, it's very important to draw the principal axis. This is the principal axis. Now this is the incident ray which is falling on the reflecting surface. Okay, these are the two incident rays. Now the reflected ray is coming over here like this. It's falling back. If you observe, both of them are meeting at a certain point, that too on principal axis. Remember, every point which is to be formed by the two reflecting rays, when they meet at a certain point, should be drawn on the principal axis. And this is principal axis. Always remember, whenever you are drawing the ray diagrams, principal axis is really important. So this is what? This is the point where two reflected rays are meeting. This is a certain point, whatever it is. This is an example of concave mirror. So real image किस type of mirrors में form होती है? Real image is formed in concave mirror. This point also you can note it down. So this was everything about the real images. Now for virtual images, let me erase this everything. So let's talk about virtual image. First point of virtual image is that the reflected rays do not meet at a certain point actually, but they tend to appear that they are meeting at a certain point. Now let me write down the definition of that. How in the convex mirrors. So this is the definition, guys. Please note it down. Very very important. पूछे जा सकते हैं एग्जाम में 2 और 3 मार्क्स के लिए, राइट द डिफरेंस बिटवीन वर्चुअल इमेजेस एंड रियल इमेजेस, बट दिस इज अ वेरी रेयर क्वेश्चन. इतना ज्यादा इंपॉर्टेंस इस क्वेश्चन को नहीं दिया गया है. क्विकली नोट करो. व्हेन रिफ्लेक्टेड रेज डू नॉट मीट एक्चुअली बट अपीयर टू मीट एट अ सर्टेन पॉइंट इज कॉल्ड एज अ वर्चुअल इमेज. सेकेंड पॉइंट मैं इधर लिख रही हूँ. सेकेंड पॉइंट विच इज वेरी इंपॉर्टेंट अबाउट द वर्चुअल इमेज इज दैट द इमेज फॉर्म्ड इज एरेक्ट. इमेज फॉर्म्ड इज एरेक्ट, दैट इज अपराइट, सीधी होती है. वही रियल इमेज में इन्वर्टेड होती है, बट रियल इमेज में इन्वर्टेड होती है, बट वर्चुअल इमेज में वो सीधी होती है. एरेक्ट. एरेक्ट इज अ वर्ड यूज्ड फॉर upright images. And the third one is they are not obtained on screen. They are not obtained on स्क्रीन। एग्जाम्पल, सुबह सुबह उठ के आप क्या देखते हो? सुबह सुबह उठ के तो आप मिरर पे जाके आपकी गंदा फेस देखते हो। बुरा मत मानो, गंदा यानी कि आपकी फेस गंदा नहीं है, क्योंकि सुबह सुबह उठे हो, ब्रशिंग भी नहीं किए, मुंह भी नहीं धोए, तो क्या आपकी फेस खूबसूरत दिखेगी क्या? बोलो, नो राइट, इट वुड बी लुकिंग डर्टी ओनली, नो। तो आप फील मत हो। And these type of images are always formed in convex mirrors. Remember, this type of images are always formed in convex mirrors. Real image कहाँ form होते हैं? Concave में, और ये convex में. Now I will draw the diagram for you all. See, I'm drawing same. This is a convex mirror whose reflecting surface is bulged outwards. Principal axis is very important. Okay, ये है हमारी instant ray. This is the reflected ray which is falling back. This is another instant ray, and this is another reflected ray. Now always extend reflected ray backwards. Now they're not meeting actually, right? They're not meeting actually, but extend it behind. Are they meeting or not? Where are they meeting? Behind the mirror, right? Behind the mirror. So they do not actually meet, but they tend to meet at the focus. ये होती है focus. This is the center of curvature, and this is focus. This is pole, and this is the center of curvature. ये सब कुछ हम पढ़ेंगे, but this is actually the concept of virtual images. They do not actually meet, but they tend to meet. Okay, they actually do not meet, but they appear to meet at a certain point. Okay guys, now let's get into the next topic, that is types of mirrors. We have just now discussed about types of images. Now as we have discussed about types of images, types of mirrors is very easy topic to be covered. Types of mirrors, we have two types of mirrors, plane mirrors and spherical mirrors. Okay,
we have two types of mirrors. एक होती है plane mirror and the other one is spherical mirror.
And in the spherical mirrors, we have two types of mirrors. One is concave and the other one is convex. Now, whoever has a doubt in concave and convex, watch it very clearly now. Listen to this lecture very clearly, because I'm explaining this in a very detailed way to you guys. जैसे कि मैंने बताया कि concave wave कैसे होता, concave mirror कैसे होती है, ऐसे होती है ना, यानी कि ये सब कुछ होती है reflecting surface and this is polished surface. कॉनकेव, केव याद रखना, केव कैसे होती है? ऐसी होती है जिसमें रिफ्लेक्टिंग सरफेस ऐसी होती है और पॉलिश सरफेस ऐसी होती है. एंड व्हाट टाइप ऑफ इमेजेस आर फाउंड इन कॉनकेव मिरर्स? द इमेजेस फॉर्म्ड विल बी रियल इमेजेस. ओके, द इमेजेस फॉर्म्ड विल बी रियल इमेजेस. नाउ द प्रॉपर्टीज ऑफ कॉनकेव मिरर्स आर दैट रियल इमेजेस ऑलवेज स्टैंड erect. So real images are always erect. Suppose if you take a spoon also, bring a spoon and check it out now. If you take a spoon like this, you find, if you keep your spoon very long distance from you, you will find that yourself are inverted. You are inverted. You appear to be very small in size, very, diminished, highly diminished. But when you bring the spoon towards you, will find that you are now an erect image. You are not the inverted image, you are now erect image, and even the image formed will be highly magnified. So concave mirrors के दो properties होते हैं. Concave mirrors के दो properties होते हैं. So this is the only mirror which shows both type of properties. एक तो है दूर रखने पर हम देखा जा सकता है. This is formed by, this is a type of real image, that is the reflecting rays meet at a certain point. Okay, this is a real image. So this is everything about the concave mirrors. Users also will discuss. Now talking about the convex mirrors. Convex mirrors are highly opposite to concave mirrors. अब convex mirrors कैसे होते हैं मैं बताती हूँ. Concave mirrors look like this. They are bulged outwards. The reflecting surface is bulged outwards. Okay, it is bulged outwards, and the images formed will be virtual images. Virtual images in the sense they actually does not meet, but they tend to meet at a certain point. They appear to meet at a certain point. So these are called as convex mirrors, and the image formed will be diminished and upright. Okay, the image formed in convex mirrors will be diminished and upright. Now let me create a small table for this concave and convex. So it will be diminished. That is the reason why convex mirrors को हम यूज करते हैं हमारे पार्किंग लॉजेस में. एक बड़ा सा मिरर आपको देखेगा which is bulged outwards. तो वो होती है convex mirrors. Why is it big? Why is it installed over there in our parking lodges? That is because convex mirrors gives diminished images. Diminished यानी कि छोटे से images देते हैं. So when they give smaller images, they give us a widespread view what is happening in the surroundings. So whenever we take our car reverse or go forward, we can easily observe that who is coming here. Okay, who is coming in between, so we can easily find that. That is the reason we convex mirrors को use करते हैं लोग parking lodges में install करते हैं. So concave और convex की मैं अब एक table बना देती हूँ ताकि आपको clear हो जाए. So guys, these are the basic differences about concave and convex mirrors. कि they are curved inwards. They are curved inwards या फिर their reflecting surface is bulged inwards. Convex mirrors reflecting surface is bulged outwards. Concave mirror, this is a converging mirror, and convex mirror is a diverging mirror. Virtual होती है and concave mirror कैसी होती है? It shows two kinds of properties. एक तो होती है दूर जाके अगर आप देखें it will be inverted and diminished, smaller in size. This is for far away. जब आप दूर लेके जाओगे ना तो तब ऐसे दिखेगा. Whereas when you bring it very near, no, क्या होती है? Erect and magnified. ठीक है, अब बात करते हैं कॉन्वेक्स मिरर्स की. कॉन्वेक्स मिरर्स दिखाते हैं हमें erect images and highly diminished images due to which they are installed in our parking lodges, or as it is diminished, it gives us, it's very diminished in a smaller size, it gives us widespread view of that particular area. Okay, as it is diminished, it gives widespread view of that particular area. Okay guys, now let's talk about plane mirrors. So we have discussed the concave and convex mirrors, which are two types of the spherical mirrors. Now we have one more type of mirror, plane mirror. If we discuss this, it is clear. So dressing table, पता है ना आपको, उधर एक मिरर होती है जो आप रोज सुबह उठ के आपके फेस देखते हो. तो वो कौन सा मिरर है जिसमें आप फेस देखते हो? वो है हमारी प्लेन मिरर जिसमें आप फेस देखते हो. तो प्लेन मिरर के ऐसे क्या प्रॉपर्टीज है कि आप प्लेन मिरर को आपके ड्रेसिंग टेबल के मिरर में अटैच किया, क्यों नहीं आप कॉनकेव और कॉन्वेक्स मिरर्स को इंस्टॉल किए? प्लेन मिरर हैज अ फ्लैट सरफेस. एक तो ये पॉइंट है कि प्लेन मिरर क्या होती है? एक फ्लैट सरफेस होती है. प्लेन मिरर हैज अ काइंड ऑफ फ्लैट सरफेस. Second is the image formed will be virtual. So plane mirror forms a virtual image, and the next property is that it is laterally inverted. Virtual यानी कि आप समझ सकते हो ना कि कौन से images form होते हैं. Real image यानी कि they meet at a certain point, but virtual in the sense they do not meet at a certain point. They actually do not meet, but they appear. They tend to meet at a certain point. We will find that the focus, backside focus, but we will talk about that. So the image formed will be virtual, and the next one is laterally inverted. Now suppose if I raise my left hand in my mirror, it will show it is right hand. So LHS will appear like RHS and RHS will appear like the LHS. LHS RHS तो पता है ना, left hand side and right hand side. And the next one is noises. The next one is erect. The image will be upright. It is not going to be inverted. Okay, just don't worry. आपकी image जो होती है, अगर आप ऐसे खड़े हो, क्या आप ऐसे दिखते हैं? नहीं ना. तो अगर आप ऐसे खड़े होते तो ऐसे ही दिखते हैं. So this is erect, and the size of image is always equal to the size of the object. ये distance is also the same. ये this is a daily life example यार, जो रोज आप उठ के देखते हो आपकी सुंदर सी कोमल सी फेस को. So this is about plane mirror. If you are asked about write the properties of plane mirror, you should write all these properties. I have written it in a simple form, but you should write it in a detailed way. जैसे कि मैंने points अभी cover कर लिया. So take the screenshot if required. Okay guys, now the most important topic of our 10th grade is here. अब से concentrate करना मत भूलो. So today we will be discussing today's important topic is स्पेरिकल मिरर्स। दिस इज द मोस्ट इंपॉर्टेंट टॉपिक। इस चैप्टर का मोस्ट इंपॉर्टेंट टॉपिक क्या है? तो आप बोलोगे स्पेरिकल मिरर्स मैम जी। तो स्पेरिकल मिरर्स इज नथिंग बट whose reflecting surface is a part of a hollow sphere of glass। देखो स्फीयर कैसी होती है? ऐसी होती है। इसमें अगर आप कट कर दोगे हाफ पार्ट, तो ये जो हाफ पार्ट होगी ना, दिस पार्ट इज द रिफ्लेक्टिंग सरफेस। देखो ऐसी आती है। ये जो पार्ट होती है वो होती है रिफ्लेक्टिंग सरफेस, whose reflecting surface is a part of a hollow glass sphere या hollow sphere of a glass। सो होलो स्फीयर को अगर आप हाफ में कट करोगे, एक पार्ट निकाल के लोगे, तो ये होती है हमारी रिफ्लेक्टिंग सरफेस, इज अ पार्ट ऑफ अ होलो स्फीयर ऑफ ग्लास। ठीक है, सो दिस इज एवरीथिंग अबाउट स्फेरिकल मिरर। तो इसमें भी दो तरह के मिरर्स होते हैं। वो होती है, एक होती है कॉनकेव और एक होती है हमारी कॉन्वेक्स। कॉनकेव एंड कॉन्वेक्स मिरर्स, नाउ आई विल ड्रॉ इट क्लियरली एंड शो यू गाइस, सो वॉच दिस वीडियो केयरफुली। सो स्फेरिकल मिरर्स आर वेरी वेरी इंपॉर्टेंट टॉपिक। यही है हमारी बहुत ही इंपॉर्टेंट टॉपिक। यही टॉपिक है जिसमें बहुत सारे लोगों को कंफ्यूजन होती है। देयर आर लिटरली so many terms which have to be covered in this topic. So let me draw the figure first. My concave mirror. So this is concave. This is the polished surface outside. So this we should draw. This is nothing but the center of curvature, या फिर the center of the sphere. Here we will have the focus and here we will have the pole. This is principal axis. Okay, this is principal axis. Now this is center of curvature, this is focal length. See, this is focus and this P is nothing but pole. Now this is the polished surface. This is the polished surface and this one is the reflecting surface and this one is the reflecting surface. This is the polished surface, this is the reflecting surface and जब हम किसी और की बात करें, we even have this radius. ये क्या होती है? पूरा रेडियस होती है and this is focal length. This is focal length. Focal length is always denoted with a small f and focus is denoted with F, capital F. F is equals to R by 2. This is a formula you should remember. क्योंकि F को अगर देखो तो F कितने पार्ट्स में डिवाइडेड है? अगर आप F को 2 is equals to R is equals to 2F. So F is equals to R by 2. So in this way we got F. F is nothing but focal length. Now let us discuss all of this definitions, such as center of curvature, what is center of curvature, what is focus, what is focal length, pole and radius. This everything we will discuss it clearly now in a definition form. Focal length की ये जो formula है, it's very important because it will be used to solve some numericals. Okay, so if you look at here, now first of all let's start from here. What is center of curvature? Center of curvature is the center of the spherical mirror. Okay, it is the center of the spherical mirror. Hollow sphere का center होती है। Next, अगर आप इधर R को देखो, we have denoted it as radius. So it is the distance between center of curvature and pole. ये होती है radius. अगर आप एक hollow sphere का लेके अगर आप diameter बनाओगे, तो ये होगी हमारी diameter. Now this diameter के साथ साथ ये क्या होती है? ये होती है radius. अगर आप diameter को half कट लोगे, तो ये क्या बनाएंगे? Radius. So this is only will be the seat, this only will be the pole, and here in between we have the focus. Now what is F? What is focus? Focus is nothing but a point where all the reflected rays meet or they appear to meet. That is focus. Okay. About pole. Pole is a place where the principal axis strikes the mirror. तो principal axis क्या कर रही है? Principal axis, suppose this is a concave mirror, क्या हो रही है? Principal axis तो draw करेंगे. तो principal axis जहाँ पहले mirror को strike करेगी, principal axis जहाँ पहले mirror को strike करेगी, that point is only pole. ठीक है, pole is nothing but it is a point where the principal axis first strikes the mirror and focal length is nothing but F is equals to R by 2. F is focal length is nothing but it is the distance between focus and point. F is equals to R by 2. Convex mirrors की shiny surface यहाँ होती है, तो ये है हमारी convex mirrors की shiny surface. अब शुरू करते हैं इधर से. प्रिंसिपल एक्सिस इधर से आती है और स्ट्राइक बनाती है। पहली स्ट्राइक कहाँ बनी, इधर बनी, तो इसको क्या बोलते हैं, पोल बोलते हैं। ये है हमारी सेंटर ऑफ कर्वेचर, यानी कि पूरी जो हॉलो स्फीयर है उसकी सेंटर को बोलते हैं सेंटर ऑफ कर्वेचर। इन बिटवीन द पोल एंड सेंटर वी हैव द फोकस वेयर ऑल द रिफ्लेक्टेड रेज कम एंड मीट और दे अपीयर टू मीट, तो इसको बोलते हैं फोकस। तो ये हो गई पोल, ये हो गई फोकस, ये हो गई हमारी सेंटर ऑफ कर्वेचर, एंड दिस इज द रेडियस एंड दिस इज द फोकल लेंथ। इन द सेम वे r is equals to 2f एंड f is equals to r by 2। ठीक है, ये फॉर्मूला अगर आप भूल गए तो पूरा का पूरा, एंड दिस इज द restover part of the hollow sphere, okay, this is the restover part of the hollow sphere, you should not take this into consideration। ठीक है, this is the restover part, इसको और भी थोड़ा विड्थ बना दे तो सेंटर ऑफ कर्वेचर अच्छे तरह से दिखाई देगा कि हाँ वो जो है इट इज सेंटर ऑफ कर्वेचर। ठीक है, सो दिस इज अबाउट द कॉन्वेक्स मिरर्स एंड द सेम टर्म्स आर देयर। आई हैव एक्सप्लेन ऑल दिस टर्म्स, रेडियस, फोकस, अभी भी मैंने एक्सप्लेन की जब मैं लिख रही थी, अभी भी मैंने एक्सप्लेन की थी। सो आई होप दिस इज ऑल्सो क्लियर फॉर यू गाइस। Now guys, I just want to end the face-to-face interaction over here because next topic is rules to obtain images formed by concave and convex mirrors, in which I want to discuss in the form of a paper because it would be more convenient for me to give it and even it would be more convenient for you to understand the topic. So what I do is rules to obtain the concave and convex images. I will show that in a paper. In the same way, images formed in the concave and convex mirrors also I want to show it in a piece of paper only. So I'll meet you all there. So let's switch our camera to the paper side.